Okay, let's learn some trig. So, suppose we have a right triangle, and we all know a right triangle is just a triangle with a right angle in it. So let's draw a right triangle here. And we're going to label this triangle using capital letters for our angles and lowercase letters for the sides. That's really important. You want to stick with this the rest of your life, really. You got to keep your angles different from your sides. I'm going to label this triangle ABC, where capital A, B, and C are my angles, and C is the right angle. We're always going to have capital C be our right angle. Then across from each of those sides, so across from angle A, over here, this side will be side little a. And across from angle B, over here, this will be little b. And across from the right angle will be the hypotenuse, C. So little c will always be the hypotenuse and across from the right angle. Okay, we know, for example, something that's going to come in, be important later. We know the Pythagorean theorem. C squared is A squared plus B squared. That's going to be important all semester long. That's an ugly H there. Let's fix that. Okay, now based on this triangle, we're going to write some definitions. Well, we're going to write these in general first, and then we'll come back to this particular triangle. We're going to define the sine of some angle theta, which we abbreviate sin of theta. So theta here is an angle, to be the length of the side opposite theta divided by the length of the hypotenuse. We're going to define, so this is a definition, the cosine of some angle theta, which we abbreviate cos of theta, COS, to be the length of the side adjacent to write that a little prettier. Adjacent divided by the length of the hypotenuse. And then we're going to define tangent of some angle theta, which we abbreviate tan of theta, to be the length of the side opposite over the length of the side adjacent to that angle. Okay, so like when we do some examples, this will make sense. We've got this new word here, adjacent. What does adjacent mean? Adjacent means next to, right beside. We know what the hypotenuse is. That's a fixed side of the triangle. And opposite means across the triangle from the angle we're talking about at that moment. Okay, these are our big three. These are the three you absolutely have to memorize. And the shortcut for memorizing these is this mnemonic, so katoa. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, then we also have what we call our reciprocal trigonometric functions. We have secant of some angle theta, which we abbreviate SEC of theta, and that is the length of the hypotenuse divided by the length of the adjacent side. Cosecant of any angle theta, CSC of theta, is the length of the hypotenuse divided by the length of the opposite side. And then cotangent of theta, abbreviated COT. And this is adjacent divided by opposite. Okay, let's look at drawing an actual triangle I'm talking. So let's go back to our triangle we drew up at the top. We've got ABC. So that gives us side little a, little b, little c. So if I wanted sine of A, we're always taking sine of an angle. Sine is a function. You put angles into it, and it spits out fractions. So here the input, the argument of this function is this angle A. So from angle A, I want opposite over hypotenuse. So from angle A, the opposite side is little a, and the hypotenuse of the triangle is always little c. What about cosine of angle A? So I'm sitting at angle A. Cosine of any angle is supposed to be the length of the side adjacent, meaning right next door, divided by the hypotenuse. So from angle A right here, there are two sides that are next door. We've got side B over here, and we've got side C. Those are the two right next to A. This one already has a name. That's the hypotenuse. He can't be adjacent because he's already got a name. So when we say adjacent, we mean the one right next door that's not the hypotenuse. So that will be B over C. What about tangent of A? So from angle A, opposite over adjacent, opposite over adjacent. So from angle A, the side opposite is little a, the side adjacent is little b. Okay, what if I use the other angle instead? What if I wanted sine of angle B? So now this is my angle that I'm talking about. When I say opposite, I mean opposite from whatever angle I'm talking about at that moment. So opposite from angle B will be side little b over hypotenuse. What about cosine of B? So from angle B, I want adjacent over hypotenuse, the one next door over the hypotenuse. And tangent of B. Opposite over adjacent. From angle B, opposite is side little b, adjacent is side little a. Okay, so some notes we want to make here. These are really important. First off, there's no such thing as the opposite side in a triangle. A triangle doesn't have an opposite side. A triangle has a right angle. A triangle has a hypotenuse. Those are the only things that are fixed. When I say the opposite side, I don't mean some designated side in the triangle. I mean opposite from some angle. So you have to figure out what angle you're talking about first, and then we mean opposite from that. Opposite from angle A is little a. Just goes across the triangle. Opposite from angle B is side B. Okay, next, these trig functions are functions. Like f of x. Remember f of x from college algebra? You have to have an input. They must have arguments. You will never in your life ever write just this. It's always sine of something. And secondly, when I say like sine A, that's not sine times A. This means take the sine value of some angle A. So it's of, it's not times. That's not cosine times A, that's cosine of A. Okay, let's use this same triangle and find our other three guys. So just to redraw him real quick. Okay, so let's find secant of angle A. So recall, secant of any angle is the length of the hypotenuse divided by the length of the adjacent side. And when we say adjacent, we mean adjacent to angle A. So I'm here at angle A. The hypotenuse is always going to be little c. Adjacent to angle A is side B. It's right next door. Cosecant is hypotenuse C over opposite. I'm at angle A. Opposite angle A is little a. Cotangent is adjacent over opposite. Secant of angle B. So now I'm at the other angle. Now my adjacent and my opposites switch around. Still hypotenuse over adjacent, but I have a different adjacent now. Hypotenuse is still C, but adjacent to angle B is side A. Cosecant is hypotenuse over opposite. That's still true. But now opposite is different. Now opposite from angle B is side B. And cotangent, adjacent over opposite. Okay, so let's do a quick example here. Say we have this triangle. It's a right triangle. We got a right angle here at angle C. We've been given two of the sides. Length of side A is 3 meters. The length of side B is 4 meters. We want to find all this. First thing we're going to have to do is find the length of the hypotenuse. But hey, we know Pythagorean. We know this is side C here, the hypotenuse. And we know C squared is A squared plus B squared. So C squared will be 3 squared plus 4 squared. So C squared equals 9 plus 16. C squared equals 25. Now keep in mind, nobody asked me for C squared. I don't want C squared, I want C. So I have to take the square root of both sides. And technically I'm supposed to put a plus or minus over here. Anytime you take the square root of both sides, you're supposed to put a plus or minus. But we're talking about lengths of a triangle here. And we know those can't be negative. So we'll just have C equals 5 meters. Okay, now we have our triangle. By the way, this is what we call a Pythagorean triplet. A 3, 4, 5 triangle. That is going to come up a lot. There are a lot of these triplets where we get nice, pretty numbers for all three sides. And you really just want to kind of memorize some of these. 3, 4, 5, 6, 8, 10... 5, 12, 13 is one. You'll see, these will come up a lot. Okay, now let's find some of these trigonometric functions. So sine of A is opposite over hypotenuse. SOHCAHTOA. SOH, sine is opposite over hypotenuse. 3/5. Opposite from angle A, because that's the angle I'm talking about. What about cosine of A? So from angle A, I want adjacent and hypotenuse. That would be 4/5. Tangent of A, opposite over adjacent. SOHCAHTOA, TOA. Tangent is opposite over adjacent. And secant. Now, in the next video, I'm going to show you some nice identities. I don't have secant memorized. I know that secant is just cosine flipped over. We're going to do that in the next video. But for now, the way we wrote secant down, hypotenuse over adjacent, Secant of angle A will be hypotenuse divided by the length of the side adjacent, in this case 4. And then in the next video, we'll see that a shortcut for secant is really just cosine flipped over. Secant of any angle is cosine of that angle flipped over, or 1 over cosine. And that's a good place to stop here.